Good morning, dear students. It is rightly said that whatever we are today is because of the actions and the deeds which we have performed in our past. Similarly, before Newton have discovered the inverse square law, that is the force of attraction between two bodies is inversely proportional to the square of the distance between them, a young, a very intelligent astronomer, Johannes Kepler, between 1571 to 1630, derived the three laws based on the orbit along which the planets revolve around the sun, the area which they cover, and about the law of periods. So we're going to learn about the law of orbits. It says that the Kepler says the planets move around the sun in elliptical orbits with the sun at one of the focus. So what is an ellipse? Ellipse is a circular shape which have a proportionally symmetrical structure, and the ellipse has two axes. That is, one is a minor axis and one is a major axis. And on the major axis there are 2 points which are located equidistant from the center. That is, they are named as the two focus. So at one of the focus the sun lies, which states the law of orbits. And secondly, the law of areas, it says that the Kepler says the line joining a planet to the sun. Suppose this is the sun and this line is joining the planet. This is the planet revolving around the month of December. So the line joining a planet to the sun sweeps out equal areas and equal intervals of time. That means if a planet is it is at this point December, at this point it moves till January at this point. Okay, so it sweeps a certain area which is being colored in the blue color. This area will be equal to the area it has covered between other months like October to November or August to September. So we can mark it as Sun October November area is equal to the Sun December January area. Similarly, we can say the line joining a planet to the sun, that is this line which is joining a planet to the sun, it will sweep out equal areas in equal intervals. That means in equal interval of 1 month they will cover equal area. That is a law of area which has been stated by the Keplers. And there is one more point to note, it is that the planets are sometimes nearer to the sun, which has been stated by the first law because of the elliptical structure of the particular orbit, and sometimes they are away from the sun. And when the planets are nearer to the sun, they move at a faster speed because of the action of more strong gravity which is acting on the planets near the sun. And when the planets are away from the sun, they move a bit slower, okay, because of the lesser amount of gravity acting on the body. And when a planet is moving in an elliptical path, there are two forces which are acting, that is a radial force and a tangential force, and they add up, because of which they move at a faster speed near the sun. And the third law, which states the law of periods, it is based on the understanding that the planets revolve at a faster speed near the sun and at a slower speed away from the sun, because of which the third law of periods can be easily derived by the Kepler, that is the square of the time period of the revolution of a planet around the sun. That means the square of the time period of the revolution of the planet around the sun in an elliptical orbit is directly proportional to the cube of its semi-major axis. It's directly proportional to the cube of the semi-major axis. It has been stated with this relation, that is t square is directly proportional to the r cube. Okay, now how? What is a semi-major axis? We should understand this is a minor axis which is shorter, and this is a major axis. A half distance from the center to this point is a semi-major axis, and the cube of the semi-major axis directly proportional to the square of the time period of revolution of a planet around the sun. कितना टाइम प्लैनेट को सन के अराउंड रेवोल्यूशन में लगा, घूमने में लगा इस इलिप्टिकल ऑर्बिट में, वो t है, उसका स्क्वायर इज डायरेक्टली प्रोपोर्शनल टू r क्यूब, व्हिच हैज बीन डिराइव्ड बाय द केपलर. दिस इज अकॉर्डिंग टू योर syllabus about this particular Kepler's free law. So students, these laws are important to understand the Newton's inverse law square law, that is F is inversely proportional to 1 upon r square. I think I must have been able to explain you the theorem. So please listen attentively and please draw and write about these three laws in your copies also. Thank you students, thank you very much.